So we have time for this morning to add more information, or at least more remarks on Internet. So some people might think that Internet, well, that everybody knows that now, so what's new? Well, everything is new, not everything. A lot of things that are obsolete in Internet, including all the protocols that you're using every day. But the thing is, in Internet, there are always things that are beginning. At no point you can find something which is just beginning, so it's not worn out yet. So that's the time to get interested in it, especially if you want to be a pioneer. You know, pioneers are crazy people who are only recognized 10 or 20 years after they've started doing things. You know, think of Tim Berners-Lee, for example. Think of the people who designed the first internet, not this one, and so on. And since I was old enough to be a pioneer, because when I started to work on internet didn't exist. And on the other hand, at this point, most people think he was totally crazy. So he had to fight. When you are in the pioneer gang, you have to fight institutions for a long time before it's recognized as being something useful and workable, and perhaps better than what they had before. So since Internet was already too old when I had got my retirement, and I wanted to, the only thing I thought was the most interesting is keep working. Therefore, I kept in touch with the people who were developing new internets, and especially John Day at Boston University, who was creating RINA, or INA. I'm sure you know all about that now. But there are still a lot of people who have never heard of RINA, you know. The same way as like in 1971, a lot of people had never heard of Internet. So let's see a few examples of the way things are typically going when you're in fields which are pioneering or innovating and so on. You have typically, I'm sorry, that's not, it's it.
Tu peux juste avancer avec ça.
Avance.
Là, tu dois avancer, oui, de l'autre côté. Vas-y.
But I have to get rid of this one. Okay, thanks.
Voilà.
I pushed the wrong button.
This is the part of the...
Oh, yeah, okay. It was upside down.
Quand vous bougez, il y a ça.
So we are in the context of future internets. But when those internets will be old, probably in 10 or 20 years. So it's better start thinking of the new ones, the future ones, even though there may not be at the moment in large deployment. So the next thing is, that's 50 years ago. 50 years ago when I got involved in networking. Of course, at the time, there was not many institutions working on that. There were mainly institutions working against networks, like the telecom, for example, telecom people, or the governments. Most governments thought it was a waste of time, just a toy for researchers. There would be much better things to do than inventing networks. But that, finally, it got through. So you see the progress of activities. In 1963, I went to MIT because I wanted to learn English. At the time, I had learned German in my college years, but I saw that most American companies were coming to Europe and trying to educate the European. So I think if I didn't speak English, I had no future. And then, so I went to MIT, where I not only learned English, but also programming, because at that time I was with a company called Machine Bull. And they had started developing a huge computer called Gamma 60. And the people who were working in programming the gamma system were only technical people who had never got a high degree of any kind. So, of course, they were doing good work, but the idea of conception, or the idea of agglomerate different pieces of program was not yet born. So I think learning programming, even for an engineer like I was fundamental. But at the time it was ridiculous. Engineers were supposed to manage people, but not to write programs. So after 2.5 years at MIT, I had enough knowledge to come back and try something else in France. And I just had a proposal to develop a system for the French meteorology, which were using a very old machine which has never worked. And of course, meteorology is totally obscure to most of people. It's have huge bases of data, and this is changing constantly. So doing predictive meteorology required big machines and the ability to constantly update the data set. It was very, very exciting. So I developed a system which didn't exist. It was based on, I would say it was based on Unix, except we were in 1971. And as you know, Unix was created in 79 or 69, I'm not sure. Well, at least a number of years later. But the principles were known already. The principles were in Multics, which had been developed at MIT. And since I had been working at Multics, on Multics at MIT, the idea of processes, a family of processes, writing to each other, talking to each other, was already familiar to me. And therefore, I could develop a system which I called Meteos. And it was not Unix, it was just something before Unix. Multitasking, piping, a permanent file system, because the system, the machine on which we were working was a control data 6400, a machine which only had very, very light basic systems. They had a macro assembler, a Fortran compiler, a few utilities like dumping and so on, but no permanent file systems. So what can you do with a huge machine with no permanent file systems? So we had to develop a file system, of course, hierarchical, like everybody is doing now. And meteorology started to work. They could predict weather earlier than the weather was happening, because in the first program they were doing in meteorology everywhere around the world, it would take 2 or 3 days to predict the weather. So it was a bit late, you know. So they had to not only to have very fast machines, but also to have very fast programming, the ability to constantly, in real time, swallow data coming from the west, because in the northern hemisphere, the weather is going from west to east. So they were swallowing data from the west and then piping them to the east on communication lines. And these kind of things were not done yet by computers at the time. But they were quite happy because they used the system for 15 years, you know, even though it was a prototype. After that, I got involved in another thing. It was something that at the time was becoming a little bit in fashion, is to create network of computers. Well, the one which has been very famous was ARPANET, but ARPANET was not the first. I guess in 1960-something, there were a system in Spain which had been developed by the Compañía Telefónica de España for the Spanish banks on UNIVAC systems. It was to exchange bank transactions between the various banks in Spain. It was very sparse documentation on that. The Spanish are quite, let's say, discreet about what they're doing. At least they were at the time. and therefore there was extremely few publications on that. But it was the first computer network, limited in terms in the sense it was homogeneous and restricted to some applications. But after that, you got TimeNet. TimeNet was a company, US company, which was doing time sharing. It was very in fashion, time sharing. But they had the idea of offering their competitors to use their own network which they had built, a network of, say, computers which were accessible by typewriters or something of that sort, IBM's small computers. And therefore, they got, since their competitors were not so excited in building their own networks, which is expensive, they got a lot of customers, not stealing customers to their competitors, but offering them to expand their network by using the physical infrastructure from TimeNet. And gradually, TimeNet became the first commercial computer network installed not just in the US, but also in Europe, around the world. They were operational much before the telecom operators were able to do the same thing. That's something we had to work on for some time. But in 1974, we made demos of a computer network we had called CICLAD. It was using a new technique of transmission for datagrams. By the way, the word datagrams was invented by Norwegian PTT engineers in 1976, I guess. So we did not know we were using datagrams, but everything thought it was crazy. It would never work. That was the opinion of the telecom people and also people like IBM and so on. But since we had at the time the support of the French government, it was de Gaulle time, followed by another de Gaulle Prime Minister, Pompidou. And therefore, we had the money and the possibility of going ahead, even though the PTT were strongly against it because they wanted to do their own system for data communication, which was X25. Well, they did, and they thought they had won. Well, they won for 10 years. But after that, the Americans decided that they were going to use datagrams too. It was in 1983, in other words, about 10 years later. So they developed what they called the Internet, which they thought they had invented. And then, at this point, a lot of countries in the world started to use this kind of technique, which was, in a way, very unknown by a lot of people. Communicate without having predefined trajectory or predefined way of going through a network was not considered as possible. But it was much simpler than using predefined circuits. So we did that, and it became gradually the norm, the standard. Actually, it was never officially standardized. It was published abundantly by everyone who was working on datagram networks. That was mostly American, but also we had a lot of publications because we were say, invited, or we had to work in cooperation with many other researchers in Europe and other part of Europe too. So we had a lot of publications, and finally, this became the standard for building packet networks. Of course, there was also OSI, which had been created by the World Institution for Standardization, which is called ISO in the reverse order. But OSI was open system interconnection. The ambition was to make every computer brand interoperable, compatible with each other. At the time, he was working with a network of systems from IBM, from Plessey, from Remington, from Siemens, was considered as totally impractical. They had their own standards, their own technicians, their own technical secrets. But that was the ambition of the European Union at the time. And they started this project called OSI, on which we immediately started to work in order to provide a sort of worldwide standard for interoperation of several computers. It took some time, and later on, of course, there was a lot of fight against IBM. IBM was moderately fighting us because they were mainly interested in selling their OSI, their 360 system. But as long as they still have the dominance in selling 360 machines, they were not too dangerous. So they let the people who were building OSI do their own experience. It worked for some time, but it didn't work really well, mainly because there was not enough experience for people working on computer networks. Networking computers is a little bit more difficult than just developing application on a single computer. So the lack of experience, and furthermore, a lack of well-defined goals for using those systems made it a little bit not a failure, because OSI was a success in terms of terminology, in terms of understanding the technical structure to be used for building computing systems, networking systems. But on the other hand, commercially, it didn't get that much success. It didn't get that much success because there were already, starting in 1983, there were already TCP, the first version of TCPIP, which gradually became a sort of standard for transmitting data from computer to computer. It was not that simple either, but it was at least much less entangled than OSI, which had a very complicated way of defining protocols. So finally, TCP won in terms of being a practical standard. So that went up to, let's say, the year 2000 and something. This is the time where the United Nations thought that computing was a fantastic capacity of changing the world, and it had to be developed and, let's say, expanded into the whole world. That's where they created the WSIS. It was a worldwide system of information. I'm not sure what exactly. It was the idea, again, to have a sort of an aggregate of studies to make the whole world communicate with the same standards and possibly develop their own applications for their own needs so that they could develop in their countries. Okay, so we were part of that. But then it turned out that it didn't work either too well, at least not fast enough. So in 2012, I had heard of a very interesting technology developed at Boston University, an internet much more simpler, not the complication of and the insecurity. TCP was not secure. So John Day from Boston University worked maybe almost 10 years on creating a new concept, which he called Recursive Internet Architecture, RINA. I immediately became excited on that. I said, that's what we need. And I started to become, let's say, an activist in it, not working on the development, but an activist in speaking. And finally, we're here, and you're here, and you're working on RINA, with the use of RINA. So it looks like it's not been lost in forgetfulness. So now a lot of people are working on it, and we had created a sort of platform for exchanging between any protocol and the existing internet legacy that we call OpenRoute. OpenRoute was not an invention, it was just an arrangement allowing new internets or new whatever network you want to do to be able to communicate without much problem with the existing internet legacy. And when John Day worked on find out about that, he said, well, that's what we need for RINA. So RINA is going to be the platform for exchanging between internet legacy and the rest of the world. Okay, so now what, a little bit further things? Well, it's right. Oui, j'accélère. OK. Alors, ça va. Where is he? Oh, that's right. This one. So what we created is a system which allows a diversity of network. ICANN being one of them, the big bar here. But anything can be added to it, you know. For example, at the moment, you have the ICANN network, which everybody calls Internet. That's the one to right. And then you have Google network, which is independent of ICANN, except they use the same database. Well, actually not quite, but very similar. And OpenRoute is one of them, but there are maybe 20 or 50 networks of that sort at the moment. It's not very official. So that's based on RINA with the various projects which are derived based on RINA, Irati, Pristine, Arcfire, Carina, and you know that, you know. And that's now the trend that started. It's now becoming fashionable, but we may have to wait a little more years because we are, again, disruptive for the existing or theories or the existing agreements which have been built over the past 10 years on Internet. And the idea is that you have a bunch of OpenRoute systems which are used by anybody, which have networks of their particular control, particular protocol. They can all communicate with each other with the appropriate conversion done through the modules necessary on OpenRoute to make them compatible. So it's not a disaster for the existing industry. Instead of keeping producing TCPIP legacy, they can now get involved on RINA. An example of what we get with these new conventions, you don't have to be ICANN compatible. You can create something new. It's compatible, of course, by the various platforms, but you can have your own network with your own domain names, your TLD of any kind, whether it's Russian or whether it's and so on, Chinese, and that's it. So we hope it's going to be the future, but it's coming fast now. Thank you.